So good afternoon, everyone. I'm Tony Bergantino, Director of the Wyoming State Climate Office and the Water Resources Data System. We're in the Department of Atmospheric Science here in Laramie, where yesterday you could tell it was a typical Wyoming spring day. I had rain followed by hail, followed by snow, and then a combo of rain and snow into the evening. So it was a pretty mixed bag here. Thank you all for joining us for the May conditions briefing, which is put on by my office along with the University of Wyoming Extension, the U.S. Geological Survey. We have the State Engineer's Office with us and the U.S. Bureau of Reclamation. We have the Missouri River Basin Forecast Center. And for our monthly highlight, we have the National Drought Mitigation Center and University of Nebraska and Lincoln joining us. So today, as usual, we'll be going through the current drought status and conditions, followed by stream flow, reservoir conditions, water rights administration, and then some weather forecasts, outlooks, water supply. And then for our highlight of the month, we'll be showcasing the VegDRI product, which looks at the vegetative response to drought. So speaking of drought, here is the current drought monitor map showing the conditions as of Tuesday, the 13th. We've seen some improvements across the northern part of the state, which has finally been getting some precipitation that's been making a difference. This extends down into the lower part of the wind basin and the upper Green as well. But unfortunately, we've also had a bit of degradation in the southwest where some range conditions have worsened and flows are running below median in areas. On the left here, we have the drought map from 1 year ago, with today's being on the right here. These maps didn't look as bad until I doodled the lines all over them. The green area in the north, as well as that spot in the upper Green in Sublette County, they're at a better drought category than they were at this time last year. That's the good news. The bad news is that huge red polygon that covers about 2/3 or so of the state, almost the entire southeastern half, as well as a good bit of change of the west central Wyoming. That area is at a worse category than we were at this time last year. Hopefully this current bit of precipitation will help whittle away at least some of those abnormally dry areas. So here's our 25-year history of drought statewide. We're currently with 38.61% of Wyoming being in one of the D1 through D4 categories, which are the categories that represent actual drought conditions. That amount is a little over 13% from the last time we met back in April, and it's largely a result of the improvement of several areas that were in moderate drought before. Those have gone to D0. Taking into account all the categories, though, including that D0 or abnormally dry conditions, we still have just 77, a little over 77% of the state impacted, but that is down about 2% from last month. Looking at the last 5 years and change, we see a decline in the area impacted quite a bit over here on the left side of the or right side of the chart. Unfortunately, we have that D3 still trucking along pretty much about even there. So with that, we stand unchanged from last month at just about a little over or a little under 8% of the state in that category. All of that being that red blotch in the southeast, and same area that we saw last month. The amount of state completely devoid of any D category is now at almost 23%, which has gone up just over 2% from the last time we met. All right, precip over the last 2 weeks, it's been mixed. The western mountainous area missing out. South central Wyoming, pretty much most of Carbon County, southern Carbon County at least, also got passed by, as did the far west. Remainder of the state has been right about median, a few areas above or below. The most above has been right in the center of the state and then up in the Bighorn Basin. Stepping back 3 months, we have that diagonal pattern sort of setting up again. Much of the northwest half of the state above median, except for the south side of the winds. And then we have the south side of that, or the southeast side of that diagonal, which has been below median. We look at precipitation accumulation over quite a few different time periods, and two of those are the water year and the calendar year. The calendar year obviously is accumulating since January 1st. And the water year is that which accumulates since October 1st and is used as, that's the date when flows are typically minimum, snowpack begins to build for the next season. And so that's used as another type of quote unquote year. And so we have water year here on the left and calendar year on the right, and you can definitely see some similarities and patterns between the two, a bit more so than we've seen at other times. Both of them, the west to northwest has been below average, as well as some of the much of the southeastern 2/3 or so. Then you have normal to above normal in the green, and upper green really, the Wind Basin, Bighorn Basin. Then the far northeast is average to above average as well. The one thing that sticks out is that the calendar year generally shows it being more above average, especially in the areas that are above normal. That just shows that areas where we got more of our precipitation was in this calendar year rather than the buildup in October through December. So on to the standardized precipitation index map, the SPI. Going clockwise from the upper left, we have the 1 month, 2 month, and then the 1 year down here on the bottom right. The 1 and 2 show some nice wetness in the north central and even northeast. In the south, though, some drier conditions in southern Carbon County. They're drier at the 1 month compared to the 2 month map, showing a worsening of conditions there. And then the 1 year depiction down here on the bottom right is still average to dry across the entire state, except for a few inconsequential little blurbs of blue up there in the Bighorn Basin. East central part of the state is the worst and somewhat coincides with that area, still showing the severe and extreme drought conditions, and then pushing across into Carbon County, which we mentioned earlier. Okay, minimum temperatures up here on the right in the lower elevation areas finally been above freezing mark, with just the higher elevations now seeing those nighttime lows getting down below 32. If we look at those temperatures in terms of comparing them to normal, down here on the left, we can see it has been pretty much above normal statewide. Fairly scattered, but the west and northwest do stand out, along with a few areas in the southeast. A few areas that saw normal temps, those gray areas, but they're pretty few and far between. Looking at the maxes, so for daytime highs, really we're well above freezing statewide, with average highs in the Bighorn Basin and other parts in eastern Wyoming averaged mid-70s over the last 2 weeks. Even the mountains were mostly in the 50s or higher, except for the very uppermost parts. Max temps were also above normal the last 2 weeks, as you can see down here on the left, and to a greater degree than the minimum were. Much of the north, the west, and east were more than 10 degrees above normal, with the south central parts being the least positive departure, though still above normal. But even there, it was 3 to 4 degrees above. After some improvements, soil moisture is once again deteriorating pretty much statewide. The very low percentiles in the southeast have expanded westward in the last 2 weeks, although southern Laramie County does register a little bit of improvement there when you look at it compared to the map on the left. The western 2/3 have gotten worse or stayed the same in a few places, but generally have gotten worse. Unfortunately, this map is pretty self-explanatory. There's no basin in the state now that's doing better this year than last year. Last year, we had 5 basins that were between 5 and 20% below the median, with the rest being above. This year we have 5 basins that are below 50% of median, and our 2 highest basins, the Snake and the Upper Green, are only at 75%. So even those are lower than the highest ones we were seeing, or those are lower than the lowest ones we were seeing last year. Been a note about percentages this time of the year. We're into the meltouts, so the snow water equivalent or SWE curve can be pretty steep. So a few days one side or the other of the normal line can make a big difference, when you're dividing that to figure out a percentage. But regardless, we are below where we were last year. I have a bit of hope for some sort of reprieve from all that over the next week to slow things down, though. But more on that later in the presentation. So here's the area distribution of the snow water equivalent as 8% of median. Same parameter as last time on the last map, but it just shows each spot on the ground rather than having one single number for each basin. So again, this is the equivalent as a percent of median, but while it gives you a better distribution of where conditions are, what they are, rather than just looking at a basin as a whole. The dots are the snow-tell sites, and those are used to calculate the percentages that were shown on that last map. And as would be expected from the last map, most of the colors here are those grays going down into the oranges and reds. Gray is about the median. The oranges and reds are varying levels of, well, lower than median. That's not to say there isn't some above median shown here in green, and even the blues and the purples, latter being mostly at the lower elevations, and a lot of it from the current round of snow that's fallen. While this map doesn't paint the biggest and brightest of pictures, let's compare it to where we were just 2 days ago. So there's less green here, the above median conditions showing, and some of the snow-tell dots are also showing worse conditions 2 days ago than now. There's a bit less red, though, those areas with less than 50% of median showing on this map from the 13th compared to yesterday's, which was today, the previous one, which is today's. But if you were paying really close attention when I switched, you would see that much of that is in areas that had absolutely no SWE on the 13th. So let me toggle back and forth a few times here so you can sort of get a visual of the differences. All right, so now that we've had that little flashcard demo to see the differences, there's an easier way to look at all this, that 2-day change, or even a few other changes if you wish. So this shows the changes really nicely. Greens and blues are positive. It's just today's minus yesterday, or minus 2 days ago. The oranges and reds are where snowpack has lessened, and then the greens and blues are where it improved. And it is encouraging to see that almost the entire snowpack area is positive. Of course, with the exceptions of the Sierra Madres and the Medbows down in the south. And you can see that area of green on the northern base of the Medicine Bows. That was pretty red on the map from today, but it was actually non-existent on the one from the 13th. I just go back and forth there a few times. All right, so this hasn't changed much since we met last month, other than that the Tongue and Yellowstone basins have added a bit more snow water equivalent, and they peaked after the last webinar. The rest had already reached peak and were starting on their way down into the meltout. The last 2 columns of numbers here show median SWE peak and the current SWE, and you can see from them that even though we do have an active week or so ahead, chances of any of those basins bouncing back up to their seasonal peak is slim to none, and none just left. The column now to watch is that last one, which is the date of the meltout, and we can see that the coming snow and see what the higher elevations will at least prolong the current meltout somewhat, we can hope. So we'll continue looking at our best and worst basins like we've done the last couple of these, just sort of get an update on them. We'll start here with the Snake that reached its seasonal peak at 108% of the median. After beginning to melt out, somewhere around the first week or so of April, it somewhat started to follow the normal line until it got to about the 1st of May, and then began dropping quicker than the normal line did. With that current system sitting over us, we did have a bit of a rebound yesterday, which you can see as the upward tick. sort of going back up there on the chart, and I expect we'll see a bit more of that over the next few days before we continue going back down. Now I'll go to our poorest performer of the season, and that would be the Powder River Basin, which only made it up to 72% of its seasonal median peak this year. Technically, the South Platte in Wyoming and the Cheyenne basins did worse than the Powder, but they're lower elevation outliers, and so we don't really count them in with the rest of the basins when coming up with these statistics. We don't see any rebound yet in the Powder, but we do have a little bit of a change in the slope of the meltout in the last day. It was sort of not a flattening, but a bending of the curve there. We're currently down to about an average of just under 2 inches of snow water equivalent for the basin. And I expect we might see a little bit of a reversal of that in the next few days, short-lived as it may be. Current system should help a bit with stream flows. For that, we'd normally go over to Aaron Fiaschetti with the USGS, but he had a last-minute emergency, so I'll continue on with his portion of it here. And so here we have stream flow conditions all around the state. These are color-coded by their flow as a percentile. The green represent quite a range. It's between the 25th and the 75th percentiles, which is what the USGS considers to be normal. And we see a mix of those on the map, such as along the Bighorn, over in the Bear, Green, up into Yellowstone Park. Above that is sort of a light blue, and those are stations that are in the 76th to 90th percentile. A number of those along the Snake, headwaters for the Green, a few other areas. And then you have those dark blue ones, and those are at greater than 90th percentile, with those levels also showing along the Snake, Wind River, scattered through the north thanks to melt and some recent precipitation. But on the other side, though, we have a few orange dots, one on the Powder, some on the Platte, and a few others as well. And those are stations that are between the 10th and 24th percentile, so down on the lower end of the scale. And then these red ones over in the southeast, where we have some of those deeper drought conditions that we saw earlier, and two stations in the Powder and the far southwest are in that 10th, 24th percentile. So going around the state to a few locations, first up to Wapiti, where we have currently well into the runoff. Okay, now we're, all right, it's not showing up on your side. All right, let me come back here. All right, 4 weeks flows around the state. These use the same color scale, which you can also see below the map. A lot of normal sites, but with the caveat that normal means it can be up to 25% above or below the median, and the majority of sites fall into that realm. All right, we're lagging here. All right, I'll just skip over here to the, is this showing up as a WAP? Okay. All right, we're into the runoff here on the Wapiti, with the Shoshone River up there. We pushed almost all the way up through the above normal category, kind of tapping on the door of the much above normal there. I'll move over into the northeastern quarter of Wyoming. We go to the middle fork of the Powder River near Barnum. Here we've gone through that above normal range. Precipitation over the next little while should help keep us up there, up near the top there. I go down here into the southeast, where we get the North Platte above Seminole. Flows here not as good, though still in that normal range. Here's a case where a station is well on the low side of normal, is in fact kind of skittering above that below normal range, or that 10th to 24th percentile. And then one more here over on the Snake near Alpine. Long, steady increase in flow that really started climbing about the 1st of May and has passed into that above normal zone. And then here's a teacup map of the reservoirs around the state. And just like in the last few webinars, most of the major ones are sitting in that 50 to 80% of capacity, although the Fontenelle is down around 45%. And let's see, the one Seminole is just under the 50 mark there at 47%. For more on the reservoirs and water operations, though, I'm going to turn it over to Liz Crusto with the Bureau of Reclamation. Liz?
All right, thanks. So starting off on the Bighorn Basin, we have Bull Lake is at 49,000 acre feet, or just 32% full. We're just releasing minimum releases right now from Bull Lake. So we're just hoping that Bull Lake will fill, and then at some point in time, irrigation demands will be needed, and we'll be releasing water for those irrigation demands. Boise is at 525,000 acre feet and 71% full. And we're releasing 1100 CFS, which is just around the downstream irrigation demand. I don't have any plans to change the flows from Boise at this point in time, but we'll be watching the runoff and the reservoir fill throughout the runoff season, and we'll make adjustments as the season progresses. Buffalo Bills at 414,000 acre feet, which is 64% full. And so it's seen some nice increases this last week. As you saw, those North Fork gauges came up. So Buffalo, we were able to store that water, and we're releasing about 1250 CFS. So let's switch over to the North Platte system. Things are a little drier down there, as Tony showed. Overall, the system is right around 85% full. So both Seminole and Pathfinder each hold about 1 million acre feet, and Seminole's 47% full, Pathfinder's 55% full, and Glendo is 79% full. So based on our forecast and using the methodology in the North Platte decree, we have advised the state that the forecasted water supply is less than that 1.1 million acre feet, but greater than 900,000 acre feet. So that means there's an increased likelihood of going into an allocation this water year. Next slide. In terms of releases, we're really just releasing for irrigation demand. We're at 2,600 CFS in that Miracle Mile and below Gray Reef, and at 2,400 CFS at Glendo and Guernsey. So we're currently in the middle of the May hay run is what we call it, and releases from Guernsey are anticipated to turn off in the next couple weeks in that early June timeframe before turning back on to full demand by July. Thank you.
All right, thanks, Liz. All right, not that we don't like her, but we were really hoping that we didn't have to have Michelle Hubbard here from the State Engineer's Office to update us on calls and the Water Rights Administration, but we do.
Yeah.
So good, Michelle.
Yeah. All right, my name is Michelle Hubbard. I'm with the State Engineer's Office. So this is our different divisions throughout the state. They're primarily divided by main rivers. And so we have Division 1 with Superintendent Josh DeBerard, Division 2, Superintendent Dave Schroeder, Division 3 up in the northwest corner is Josh Fredrickson, and then Division 4 southwest quarter is Kevin Payne. And so with that, so these slides represent the different calls for regulation within each of the divisions. And I have bolded the streams or systems that are under regulation or have become under regulation since our last meeting. So it would be nice if there were no bolded ones. However, as kind of everyone's been speaking to, we are fairly dry in the North Platte. And so we have Bear Creek, Horseshoe Creek, South Spring Creek, and Heather Creek, as well as Pass Creek, have all gone into regulation. And those are primarily in like the Saratoga area, as well as like the Wheatland area. And so, and I guess one really quick related to Division 1 and kind of speaking to what Liz mentioned about the North Platte, because the forecasted supply determined by the Bureau is less than 1.1 million acre feet. The state engineer did validate that allocation, which means that we are just reporting bi-weekly pumpage amounts on the main stem between Pathfinder and Guernsey Reservoir. And that will continue until June, until there's another forecast. But I can't imagine with our current conditions that we will have an increased supply for the rest of the summer. So we will, I guess, give an update on that in June. All right, the next division, Division 3, there are some additional streams under regulation with the Graybull River being regulated back to 1894, as well as the Bennett and Little Rock Creek being regulated back to 1900. Thankfully, that's all I have to present today. However, I imagine there will be some more in June. So
All right, we'll see you in June then.
thank you.
Thanks, Michelle. And Alex Carruthers from the Missouri River Basin Forecast Center is she's doing double duty for us today and is going to start us with the forecasts and outlooks and then go into our normal water supply. Alex?
Looking at typical hazards for this time of year, the answer is D, all of the above, or at least almost all of the above. With no ice on the rivers, there really isn't an ice jam threat. We're absolutely in the middle between transition between winter and summer, which basically just means everything goes. Tony stole my punchline at the beginning when he talked about all the weather he saw yesterday, but basically it's the time of year where you can experience all 4 seasons in about one day. Next slide, please. Looking at precipitation for the next week, a fairly wet pattern continues, with the state looking at potentially 1+ inches of rain or snow as seen in the various shades of blue and purple, with slightly more precipitation in the highest elevations. I'll note that this 7-day forecast is valid as of yesterday, so this does include the precipitation that fell within the last 24 hours. In addition to the chances of scattered showers and thunderstorms most days, another weather system is expected Sunday and Monday, which will bring widespread rain and snow with amounts of 1/2 to 1 inch of precipitation in the lowest elevations. Next slide, please. Here we're looking at the temperature and precipitation outlooks for days 8 through 14, which does include the Memorial Day holiday weekend, May 22 to 28. These are outlooks, not forecasts. So the shading on these maps correspond to a likelihood or a percentage, a probability that above or below normal temperatures and above or below normal precipitation will occur. The darker the shading, the higher the likelihood of that condition occurring, or the higher the confidence that that condition will occur. For temperature on the left, the various shades of red and orange over all of Wyoming indicate temperatures are likely to be above normal. For precipitation, the outlook leans towards drier conditions than normal. Some of the long-range models have been showing a fairly consistent high-pressure system that builds over most of the western United States, and that does tend to give us the warmer and drier conditions. Growing up in Ohio and here in Kansas City, Memorial Day weekend is when our outdoor city pools open, and the temperature outlook definitely favors you guys in Wyoming versus for any pool-going activities that weekend. Next slide, please. Here we are looking at the temperature and precipitation outlook for 1 month, which this is for the month of June. Same thing here, temperature on the left, precipitation on the right. The temperature outlook for June leans towards above normal temperatures statewide, and actually nearly nationwide for that matter. Similarly for precipitation, seeing an outlook that leans towards drier conditions than normal for most of the state. And finally, the 3-month outlook, which encompasses June, July, and August. The temperature outlook is very similar to what was shown on the previous slide. Biggest difference here is there's an increase in the level of confidence we have for this, as denoted by the slightly darker shaded. shading. We are anticipating above normal temperatures with the highest confidence, the darkest shading in the southwest portion of the state. For precipitation for the summer, the outlook for the summer leans towards drier than average conditions, with confidence in that being the highest in the north and slightly less in the southern part of the state. Perfect. Now I'll put my hydro hat back on. Snowmelt, as you guys have seen, has ramped up since April, but given the current conditions, the overall flood threat for Wyoming this snowmelt season remains lower than normal. I should point out that lower than normal does not mean zero, as I know there was at least one location that had a river product go out this week. It just means given in on average, slightly less than that. The dots on the map here indicate locations where water supply outlooks are produced by the National Weather Service. And these outlooks represent the volume of water expected to pass a given site during the spring and summer months. The map here shows April through September volumes in the Columbia and Missouri basins, and April through July volumes for the Colorado Basin. This is based off of the official forecast that's issued at the first of the month, so this is May 1. The point of this map is to show that many locations across Wyoming are forecasted to see only 50 to 90%, the orange and yellow dots, of the normal volume compared to the 30-year average. So the primary concern this year will continue to be lower than normal runoff volumes for most locations. Thanks, Tony.
All right, thanks, Alex. All right, and for our highlight of the month, we have Sagai Tadesi, who is a professor at the University of Nebraska in Lincoln. He's in the School of Natural Resources and at the National Drought Mitigation Center. He's going to be talking to us today about the VegDRI product, and I'm going to stop sharing here so that he can get his presentation up there.
Can you hear me?
You're good.
All right. So thanks for the invitation. Hello, everyone. My name is Sagai Tadesi. I'm a research professor of applied climate and remote sensing at University of Nebraska, Lincoln, and the geospatial coordinator at the National Drought Mitigation Center. Today, I will briefly introduce the Vegetation Drought Response Index, VegDRI, including its inputs, methods, and products or maps. I will also quickly show you the website for VegDRI information. This introduction targets those unfamiliar with the VegDRI, while also providing you additional insights for those who with some prior knowledge. Okay, first I would like to acknowledge my team involved in this project and the funding institution. The USGS initiated the funding in 2003 as a seed money, and the VegDRI was fully developed with the project funded by Risk Management Agency, USDA, in 2009. So it became operational since 2009. To begin with, what is VegDRI? VegDRI is a hybrid drought index that integrates satellite-based observation of vegetation conditions, climate-based drought index data, and biophysical characteristics of the environment to produce maps at a speed, at a 1 kilometer resolution depicting drought-related vegetation stress. Let me move that one. So we used a hybrid-based approach to build the VegDRI models, which consists of 3 integrated components: remote sensing, climate, and biophysical. The remote sensing component includes 2 inputs that provide spatially detailed information about vegetation patterns and conditions, which is acquired from satellite-derived NDVI. Using initially we started with AVHRR in the 1980s, and then we switched to MODIS, now to VIIRS. These 2 satellite-derived inputs are percent annual seasonal greenness, PASG, and start of the season anomaly, SOSA. The percent annual seasonal greenness measures the overall greenness integrated from the start of the growing season. In contrast, the start of the season anomaly indicates whether the start of the growing season is earlier or later than the average start of the season. The climate component includes the two drought indices, the SPI and the PDSI. We used a self-calibrated Palmer Drought Severity Index. And the third component is the biophysical component, which includes land use and cover types, soil characteristics, elevation, ecological settings, and the size of irrigated agricultural land that influence climate vegetation interactions. This slide shows the methodological steps for developing the VegDRI model and creating the VegDRI maps and associated value-added products that I will show you later with the website. The first step is collecting and processing input data. This slide presents the 7 input variables that our research team used to develop the VegDRI for the CONUS. The second step is building training data for the model using historical data extracted for specific weather station sites. And then the third step involves developing weekly VegDRI models using the multiple regression tree method. We use data mining methods in there. With these VegDRI models that we developed based on this multiple regression tree method, we used 7 gridded input data sets each week to generate the VegDRI map. That's what we do every week now. After we developed the model, then we evaluated the VegDRI before it became operational in 2009. We used quantitative and qualitative methods, which includes conducting statistical analysis of crop yields, comparing with the VegDRI during drought years, and gathering feedback from users and experts through multiple workshops. So then we established a website on the NDMC server to share VegDRI information, which has been fully operational since 2009, as I mentioned earlier. The website includes value-added VegDRI products and collects feedback from users. Let me show you the website and its information. Can you see it, please?
Yes, looks good. Thank you.
Okay, good. Thank you. This is the VegDRI website. This is the homepage, and this is for the current week. That's May 11 VegDRI. It has 3 types. This is a complete VegDRI map, and you can also limit it only for the rangelands, or also you can do for crops, for the croplands. That is masked by using land cover maps. You can download these maps into using 3 formats: PNG, PDF, and JPEG. The other value-added product that we have is the change maps. This is May 11 with the last week, but you can compare it with last year, for example, and how dry it is this current year that Tony was showing you. And the other value-added product is the loop, this animation that we do starting from the January first week until the current week. And the gray color that you see is out of season. And once it's in season, you can see a complete map. This is the last one, May 11. And we do have archives in this website. And here, actually, you can download maps starting from 2009, April. And also, you can limit it with complete data or rangeland or crops. And then you can download the data in the 3 formats that I have mentioned. We do have FAQs that explains about the inputs, the methods that we used, and also other informations that might be helpful for the users to understand the VegDRI. And the other one is the comment section that we have. We have about 7 questions, and which mainly requests what's the users to see their local areas and compare it, and then measure it, see the accuracy, and give us back their feedback. So that's the NDMC VegDRI website. Information is also available through the USGS Eros Drought Viewer and the NIDAS Drought Portal, in addition to the NDMC's VegDRI website. This slide shows the links for the websites. Lastly, scientists from various countries around the world have shown interest in the VegDRI concept. Some of the countries mentioned in this slide have requested collaboration to develop similar models and products. The NDMC collaborated or consulted to help these countries. For example, our Canadian colleagues in creating the VegDRI Canada model in 2006, and they do have their own models that could help the North American US drought monitor. In summary, integrating satellite, climate, and biophysical information enhance our understanding of drought-related vegetation stress from local to national levels. This is the main driving force behind the development of the VegDRI. A 1 kilometer VegDRI map is produced weekly, year-round for the CONUS, providing more detailed information than traditional drought maps like the US Drought Monitor. This is because it's 1 kilometer resolution. This is the near real-time VegDRI map that's available on the NDMC, USGS, NIDAS website. It provides timely data to agricultural producers and decision makers for effective drought planning and mitigation. Let me pause here. If you have any questions, please let me know. Thanks.
All right, thanks. It's a very useful tool that we use as just one of the tools when we're coming up with our recommendations for drought conditions. We look at that along with several others, but this is a very helpful one to have in our toolbox. And I'm going to reshare my screen here and then turn it over to Micah, who will take us into the Q&A portion.
Perfect. Thank you, Tony. And you can see here listed on this final slide all of the contact information for the speakers today. And if you're interested in following up with any of them, please feel free to do so using the email addresses listed here.
Micah, my email starts with B. Please delete B.
Oh, thank you. Yes, so there's no B at the start of that email address.
Yeah.
Is that correct?
The rest is right, yeah.
Okay,
Delete
perfect.
B.
Thank you for that correction.